Hello, morning everyone. I hope you all are doing good. So, welcome to another event part of DevSecOn Hungary. I'm Madhukumar Eluri. I'm the chapter leader for DevSecOn Hungary. Today we have very exciting topic on container security. So, with one of our favorite Docker captain, Waldemar. So, he won't be joining live because he's based out of Canada, but we have a wonderful, session recorded by him, which we're going to go through first, and then I will talk about some, more detailed container security aspects. So, how are you all doing today? So, can you please leave a comment where you all joining from, and if you can hear me well, see me well, so just please give a thumbs up. Cool. Well, I'm just checking the comments. Hi, Gerald. Morning. Is one of our key community manager friend from Sneak. So yeah, I definitely appreciate his support for every event I organize as part of DevSecOn. Thanks, Gerald, and thanks DevSecOn community team. Hi, but from Budapest, where you loud and clear. That's good. Nice. So we have this, a fully packed uh, topics to cover. So basically, I would first give all limit to go through that things, and probably I'll jump in later. Yeah, if that's okay. So there we go. So I think it's all good. So let's crack on. So I will just bring on Vladimir first, and then I'll join you guys later. All right. Thank you guys. Thanks for joining.
Hey everyone, my name is Vladimir Mikhalev, also known as Valdemar Pro. I wear multiple hats in the tech world. I'm a Sneak ambassador, a Cypress ambassador, a Docker captain, and I've spent over 20 years in IT. As a senior DevOps engineer and consultant, I've seen firsthand how crucial it is to build security into everything we do, especially when it comes to containers. Now we're in 2025, and cybersecurity threats are more frequent, more sophisticated, and more damaging than ever. We're no longer just worried about compromised servers or stolen databases. Container security is now front and center. In fact, over 85% of organizations currently run containerized applications in production, but as container adoption grows, so do the security risks, and attackers have noticed. That's why it's important for all of us, DevOps engineers, security professionals, developers, and system designers, to focus on container security. In this session, we'll dive into why container security matters in 2025, key best practices that every team should follow, practical examples using Docker Scout for local scanning and Sneak for continuous security checks in GitHub Actions. So let's jump in. Time is short and security waits for no one. So why does container security matter in 2025? Let's set the stage. In 2025, microservices are everywhere. Our applications might be composed of dozens or hundreds of containers, all talking to each other. This dramatically increases our attack surface. Why? Each container is effectively its own environment with OS packages, libraries, and configurations. If just one container is misconfigured or running unpatched software, that single weakness can lead to a major breach. We're also seeing a rise in supply chain attacks, a scenario where attackers don't just target your code, but any external dependencies, base images, or third party integrations you rely on. In other words, the container image itself can be a point of compromise. That's why we need to focus on what's in your base image, our runtime environment, the pipeline that builds and ships these containers. My goal today is to give you a practical approach to shift security left, catching issues early in development where they cheaper to fix, and integrating security checks into your day-to-day workflows. So what are the best practices for securing containers? Let's walk through 7 core principles that apply to Docker, Kubernetes, and any containerized environment. Larger images mean more dependencies, and that means a bigger attack surface for attackers. Whenever possible, use lightweight images like Alpine or Distroless instead of full Linux distributions. Why? Alpine is only about 5 megabytes compared to Ubuntu or Debian, which are tens or even hundreds of megabytes. Fewer packages mean fewer security risks and a smaller attack surface, which is exactly what we want. When pulling an image, never just write from Python version 3. Be specific, like from Python version 3.13.2 Alpine. This locks in a stable version and prevents surprises from unexpected updates or security issues. And never use latest as a tag. If you pull from Python latest, you don't know what version you're getting. It could change unpredictably and break your app. Even worse, an attacker could upload a compromised image under latest, and your system might automatically pull it without you realizing. Always pin your versions to stay in control. Security isn't a one-time step. You need to continuously scan for risks at every stage: development, staging, production. Tools like Docker Scout and Sneak help automate this. For example, with Docker Scout, you can scan an image with just one command and instantly see security risks. Integrate security into your pipeline from day one, not as a last-minute patch. If your container has unnecessary dependencies, libraries, or tools left over from the build process, attackers have more to work with. Instead, use multi-stage builds. Build your app in one stage, then copy only the necessary files to a final, smaller image. This removes debugging tools, compilers, temporary files. That means a smaller, cleaner, and more secure container. By default, containers run as root, which is a huge security risk. If an attacker gains control of a root container, they can spread across your system. Instead, run your container as a non-root user by specifying user 1000 column 1000. But what does this actually mean? The first 1000 is the user ID. It's just a regular non-root user in Linux. The second 1000 is the group ID, which means it's part of a restricted group. By running as low-privileged user, even if an attacker breaks in, they won't have system-wide access. Never bake sensitive data inside an image. This is a common mistake that exposes secrets if your image is leaked or pulled by the wrong person. Instead, store secrets securely in environment variables, a secret manager like AWS Secrets Manager, HashiCorp Vault, or Kubernetes Secrets. If you happen to hardcode a secret, tools like Trufflehawk or GitLeaks can detect it before it gets exposed. Never put secrets in images, repos, or logs. Scanning at build time isn't enough. You also need to monitor what's happening in production. Tools like Falco and sysdig can detect suspicious activity inside containers. For example, Falco can alert you if a container suddenly starts running a shell, which could mean an attacker has taken control. Watch out for other red flags like unexpected file modifications, high network activity from a container, containers trying to escalate privileges. By monitoring runtime behavior, you can catch threats before they become full-blown security incidents. If you follow these 7 core principles, you'll be ahead of many organizations that are still struggling with container security. Remember, less is more, less complexity, lower privileges, and minimal secrets make for a more secure container. All right, let's roll up our sleeves and try out Docker Scout in action. Docker Scout scans your Docker images for security issues and gives best practice recommendations. Before we start, make sure you have Docker Desktop 4.38 or later installed, a Docker account, and that you're signed in using Docker login. Now let's say we have a simple Node.js application. Here is what our Docker file looks like. Here we are using Node 22.13.0 Alpine because it's smaller than Node 22. That makes it more efficient for containers, but we still need to check for security issues. Now let's build our Docker image. This command packages our application into a Docker image called myNodeApp with version 1.0.0. Next, let's use Docker Scout to scan our image for security issues. Docker Scout will now analyze the image and highlight any potential risks or weaknesses. Once the scan completes, we'll see a report listing any detected issues, their severity, and possible fixes. These issues could come from system libraries, base packages, or application dependencies. Docker Scout might recommend upgrading certain components or applying patches to fix them. So why does this matter? Because local scanning helps us catch security issues early before we push the image to a registry or deploy it to production. Fixing these issues now makes our environment instantly more secure. And that's a quick look at how you can use Docker Scout to improve security in your containerized applications. Now, let's see how we can automate security scanning in our CI/CD pipeline using Snyk and GitHub Actions. Before we start, make sure you signed up for a free Snyk account at snyk.io. Go to your Snyk account settings page, find your access token, and copy it. In your GitHub repo, go to Settings, Secrets and Variables, Actions, and create a new secret named Snyk_token. Let's say we have a Node.js project. Our goal is simple. Whenever a developer pushes code or opens a pull request, we want Snyk to scan for security issues automatically. Snyk will check the container image to detect risks in the base image or as packages. It will also check application dependencies to find security flaws in package.json and other libraries. To set this up, we need to create a new GitHub Actions workflow file. We'll put it inside the .github folder, then workflows, and name it snyk.yml. This workflow automatically scans both our Docker image and application dependencies for security risks. Here we're using Snyk_token from GitHub Secrets. This is a best practice because it keeps our login details safe and prevents accidental leaks. We've covered a lot today. Why container security matters in 2025. 7 core principles from minimum images to least privilege. A live demo of Docker Scout for local image scanning. How to automate security scans using Snyk in GitHub Actions. But here's the key takeaway. Container security isn't just about tools or settings, it's a mindset. Everyone on your team plays a role in keeping things secure. Before we wrap up, here are some quick practical tips to improve your container security. Monitor runtime with tools like Falco or sysdig to detect suspicious activity. Keep everything up to date. Patching OS packages and dependencies is one of the simplest and most effective security steps. Enforce security policies like blocking deployments if there are serious security issues. A single rule like this can make a big impact. Educate your team. Security isn't just for DevOps or engineers. It's a shared responsibility across developers, QA, and security teams. Thank you so much for joining me for Securing Containers Like a Pro. I hope you learned something new and have some solid steps to secure your containerized apps. If you have questions or want to chat more, feel free to reach out on social media or join me on Discord. Let's keep learning and building secure, high-performing apps together. Until next time, stay safe, stay curious, and happy containerizing.
Cool. That was packed with so much information. So yeah, if you have any questions, just leave it on the comment. Probably we'll try to come back with some answers for you. If there aren't, I'm just checking the chat. If there's any questions, otherwise we can move forward. Yeah, I mean, those of you familiar with Waldemir, I think he's pretty active on Docker community and Snyk as a Snyk ambassador as well. So I like his background, how he did. He does a lot of chats as well. So that's why one of the reasons I invited him to talk about this Docker. He have so much knowledge on Docker. He do a lot of stuff on Snyk and yeah, containers. So I hope that was useful. So let me dive in on the other topics which I would like to cover today. So meanwhile, if you have any questions, yeah, please drop in the comment and yeah, let's so just want to flag a few comments here. Some Billy Past from UK. Rory, thank you for joining. Thanks for joining, Gerald. Ram, thanks for joining from Hyderabad all the way. Cool. Right. And I have some $25, $50 AWS credits to give away today. So those of you would like to win, please be active on the chat. Please fill the feedback form. That's how I can reach you to give away. So don't forget. Thanks, Tiki. Cool. Let's crack on now for the other topics I would like to cover. So, 1 second. Right. So that's just a overall overview of what I would like to cover. So brief on CNCF security white paper. I'm not going to go through that, but I'll give you a link and some resources which I would like you to go through. It's pretty useful. I will talk about some best practices on security on EKS, Elastic Kubernetes Service on AWS, which is my kind of specialty, building products around Kubernetes, containers, Docker, all that, and security is my key aspect of specialization as well. So I would like to go through some hardening tools like Kubebench and Dockerbench. Let's go through some vulnerability scanning, how you basically scan your Docker images, and what would be a talk without anything related to AI, right? So these days, so I'm going to introduce you to Docker Gordon AI, and then if time permits, I'll go to the Docker Slam and maybe Dockerfile best practices. So let's go on. So CNCF Cloud Security White Paper basically provides a comprehensive guide around cloud native environments and security aspects of how you basically secure your cloud native environments, with a strong focus on basically container security, which there are a few segments which they dive into those container security, which I would like you guys to go through. It highlights best practices of securing containers throughout your development lifecycle, covering like image integrity, runtime protection, least privilege access, and supply chain security as well. So this white paper also emphasizes the importance of orchestrating security, like example Kubernetes, policy enforcement, monitoring to detect any threats in real time. So that's the link. Please go to that. And if you go to like say CNCF, GitHub page, you will see the security white paper there. So let's cover some of the aspects on best practices for EKS, Elastic Kubernetes Service on Amazon. Uh, in Amazon, basically, we have the shared responsibility model between AWS and the user. So let's walk through like key security best practices areas to help you build a resilient and secure Kubernetes environment. Yeah. So some of the aspects are like identity access management. You use AWS IAM in Amazon, so for defining the roles, your policies to enforce least privilege principle. That's a ground zero. The security is ground zero in any public cloud. So this is very important for any GCP, Azure, or AWS to basically enforce a least privilege principle when you grant access. Implement Kubernetes RBAC. It's a native role-based access control for granular permissions on top of it. Pod security. Utilize pod security standards, PSS, and security context to restrict the container privileges. Run pods on non-root users and minimize the capabilities. Basically, never run on root users and give access to the users to the root level. So you always create a non-root users and basically restrict the capabilities of what the users can do. Continuously monitor the workloads for anomalies. Tools like Falco, AWS Guard Duty is now integrated within EKS. So you can see EKS runtime monitoring to detect any threats. Network security side, basically you can implement network policies. It's pretty standard to control pod-to-pod communication. In AWS, you basically can also use security groups, private clusters, VPC endpoints to restrict any external access. Multi-tenancy, so Kubernetes native, you can use namespaces, network policies, yeah, node taints, tolerations, and stuff like that. Implement resource quotas, limit the ranges to prevent any resource abuse. And detective controls, you can use CloudTrail default, for Amazon, Amazon Guard Duty, and Amazon Detective for any security monitoring. You can also use Kubernetes audit logs to track any API actions, so anything that is, to anything which is not, secure, or anything that is deviating from your other API actions. Basically, you can log there. By default, all the logs basically would be in CloudWatch, all the Kubernetes control plane logs. So infrastructure security, yeah, keep worker nodes updated, latest patches. You get those alerts in the console itself, but make sure you all security patches are updated, latest patches, and you update the nodes and control plane as soon as possible when the Kubernetes releases. Restrict direct SSH access and uh, use basically AWS System Manager to manage any security management. Like you have parameter store and securely you can show the passwords. You can use them on the runtime in your pipelines. Use data encryption and secret management. Use AWS KMS, key management service. So basically to encrypt the data in REST and also encrypt the data in transit. Use TLS security, the AWS Security Manager. Store secrets in the secret manager and Kubernetes secrets with encryption. Some people also use Vault, HashiCorp Vault as well, which is also a cloud agnostic, and you can use Vault. Regulatory compliance, you might want to use a security hub as your operations dashboard to see all your regulatory audit configurations, and also align with the security frameworks like NIST and CSI Kubernetes benchmarks. And for incident management and forensics, yeah, you can follow Amazon Detective or EKS audit logs like we explained in the past. So you can also collect those logs and create a operational dashboard to monitor all that using Prometheus and Grafana. That can be done as well. So image security, scan the container images for vulnerabilities using ECS, ECR scanning. By default, you can just basically enable them, scan and push, or open source tools. There are many, so trivia which we're gonna go through in the coming slides. So yeah, so follow these best practices. You can strengthen basically your containers running in your EKS cluster and make sure you take some actions and against attacks while ensuring the compliance and our operational efficiency. So let's go to like Kubebench. So securing Kubernetes is basically critical because it's not only complex, but it's also there's so much going on in your clusters. When it comes to production environments, you definitely want to use some sort of hardening in wherever your containers are running. So I use Kubebench professionally. No, I would differ. There are so many tools, but this is one of the open source tool that basically evaluates the security posture of your Kubernetes cluster based on CIS Kubernetes benchmark. So they validate against this benchmark, and then basically they give you a nice summary, and you address those critical issues depending, depending on the rating. So you basically want to, mitigate those risks. So it's basically what is Kubebench is basically open source tool for now to check your Kubernetes cluster to meet security best practices. It uses CSI Kubernetes benchmark as I explained earlier, so which provides guidelines securing your Kubernetes components, core components like API server, etcd, control manager, and kubelet. So it basically how it works is basically runs an automated security check against your Kubernetes configuration. It identifies any misconfigurations or provide recommendations for any remediations. It doesn't automatically remediate, but it gives you a recommendation, and then basically you work on your remediation. So tests are defined using YAML files, making it easy to update your security standards. And why I would recommend Kubebench is basically to make sure you have a hardened posture against any potential attacks in your production environment. It also helps to meet your compliance requirements, like CISA benchmarks. It also helps you to integrate in your CI/CD pipeline to continuously check all the security validations across from dev to test to UAT and production all the way. So definitely, I would recommend this tool in your pipelines. So another one which I would recommend is definitely Docker Bench. If you're using only Docker, some of the containers, you don't have any complex environment to run use core Kubernetes, then definitely Docker Bench is one of the tool that I would recommend. So Key points would be, again, this is also to make sure you have any benchmark compliance process through within your business requirements. You use CIS, no, Docker benchmarks. This and it basically follows all the CIS benchmark, Docker benchmark, which are widely recognized by security standards, and it also have dozen of security checks to ensure hardening your Docker environment where you're running your containers. So how does it scans? Basically, on a high level, you have a host configuration issues. So check if there are any loose permissions, improper file ownerships, missing security settings. So this can detect and basically can warn you. System rights and defaults. So basically, it identifies questionable like defaults that might expose your container to risk. Docker daemon security, so ensures proper Docker daemon configurations, including TLS settings are properly configured, access restrictions. Most importantly, it also audit the common vulnerabilities and exposures (CVE). It basically cross references uh, system libraries and executables against a CVE database, and then it basically summarizes you, okay, what and rank it according to the criticality of those findings. So yeah, it will help known vulnerabilities in the installed software or dependencies. You have to go through. It doesn't fix it, but you basically have to do. There is some smart one which is coming in Docker, which I'll go through in a coming slide. But for now, the Docker bench basically give you the findings, and then you basically work on your remediations. So why I would recommend this is definitely a comprehensive security baseline for any Docker environments, for security compliance, regulatory things, CIS, these benchmarks, and it supports DevSecOps in the workflows and integrate within your CI/CD pipelines as well. So let's go through some of the key aspects of vulnerability scanning for container images. So the first one would be default ECR image scanning in Amazon Web Services. So in ECR, if you're running your workloads in ECS, Elastic Container Service, or Elastic Kubernetes Service, your source of image pulling would be a ECR, Elastic Container Registry, where you store your images. So ECR basically provides you a default image scan, and it helps you detect any known vulnerabilities in your container images before even you deploy into your test environments. Yeah. So this is a very good built-in security feature in ECR that scans your container images and known vulnerabilities the moment you push the image into the registry. So it uses again CVE databases. So any container scanning tool, open source or built in, it has to have some common vulnerabilities and exposures where it can compare and basically it identify the risk in OS packages or dependencies, and basically it gives you a summary. In a high level, that's how they work. So this has basically a database which it ECR default, it scans it and it identifies the risk and it basically gives you a summarize in the console itself. You don't have to run command line. It basically all happens in console. You can also visualize all those in the console itself. So the types of scan I think it uses is basic scanning and enhanced scanning. Basic scanning basically use an open source CLAIR database if you're familiar. So you can install it in your in a Mac or locally also and do it yourself. It's CLAIR database, a vulnerability database. So basically it checks and basically give you a summary. If you opted for enhanced scanning, it powered by Amazon Inspector. It's more powerful, more deeper insights on CVSS scores, automatic rescans and stuff like that. So depending on your your usage and use case. So how ECR works is basically as soon as you build the image and push it to ECR, it triggers a scanning. If you enable it, you need to enable this scan on push, and if you do that, it basically scans immediately. It will be triggered and it scans automatically on push. So the results are generated with the severity levels like critical, high, medium, low. So all the developers can use this insight and to fix the vulnerabilities before you deploy into test and UAT and production. So this should be integrated as part of your continuous integration or your GitLab pipeline, or a CI code pipeline in Amazon stuff like that. So that would be a continuous your development life cycle. So as soon as you see anything critical, so for example, you have your criteria to deploy into test is nothing critical. Yeah, so high and medium, basically depending on it. Vulnerability you go on. If there you find any critical, okay, it's a no go. So some sort of release process around it. So you can build that and enforce that using your CI pipeline. So why I would recommend ECR's image scanning is obviously it's default. It's scan on push. It's a fantastic tool. You don't have to. It reduces the overhead on the developers to run locally or check something. So it's everything is automated as soon as you push it. It helps prevent any supply chain attacks by identifying any risk dependencies, compliance efforts, and again, you can automate using your CI/CD pipelines. So some of the open source tools I use personally are this. Docker scan. I mean, behind the scenes, it use Sneak. Sneak is a wonderful tool, as Vladimir explained briefly in his action-packed talk. But definitely, I would recommend download Sneak, go register for that, access it, play around. If you need any support, yeah, let us know. Joral or myself, we can support you. But yeah, definitely explore Snake. It does a lot of stuff, and it's pretty useful as well. So there are stuff. Yeah. So let's start with what's the built-in Docker CL I can do with Snag. If you don't want to install like Sneak and go through the interface, by default, if you run a command Docker scan and your image, the Sneak vulnerability database basically it uses and it detects the CVEs in the container images. So in the command line. So you don't have to install Sneak, you don't have to do anything, but behind the scenes, that's what Docker scan does. It provides a detailed remediation advice as well for fixing vulnerabilities. It doesn't fix auto remediate, but it gives you details of how you can do it. So it's really great for developers using Docker locally who have got used to this command line. If you want to go another level, definitely I would recommend register for Sneak, import your project. It directly very easy to integrate your GitHub projects, and it continuously scans. It gives you a nice summary. So definitely play around with Sneak and let me know if you need any help in that. On the other side, if you want any open source that you would like to run on your Mac or running a small project, uh, I would definitely recommend Trivi. But not only for small project, it also do a lot of stuff. But I mean, if you just basically doing a POC and just slowly graduating your project into a as you mature the project, it definitely helps. It scans the OS packages, it scans the libraries, even IACs if you're using any Terraform. It basically scans all those Kubernetes. It also do of bill of materials as well. It does a lot of stuff. So I would recommend install locally, play around, see if it's how it can be useful. So it's very lightweight, it's fast, it integrates again with your CI/CD pipelines. You can basically scan the images in Docker, Kubernetes, ECR as well, and it nicely integrates with the Git repositories. As I said, you can scan your Git repositories as well. So it's definitely worth checking it. Let's talk about Gordon. Docker AI Gordon. So this was recently launched. So it's really I mean, I didn't get too much hands-on with it. I'm just playing around now, but definitely I would. This is something which I would also recommend for developers who wants to integrate the AI in the pipeline, for the container securities, for or any solution integration with the Docker ecosystem. Definitely, I would definitely recommend it. Docker AI Gordon. What is it? It basically AI-driven solution integrated within your Docker desktop Docker tools, and it automates the management and optimization of your containerized environments. So it helps basically developers and operators to deploy and scale your AI ML models efficiently in containers. So if you're running your models in containers, so basically Gordon can help you to optimize it and make it more efficient. So it focuses on intelligent security monitoring, resource optimization, automating container lifecycle management using AI. So this is new. I would definitely would like to guys to use it and see what your feedback is. Talk to me so we can also talk to Docker folks and give you more overview on it if you want, or I can do a follow up on it as well. But it does a lot of stuff. I'm learning as well. I'm exploring. I know I'm exploring the tool as well myself. So the main key aspect I liked personally is automated container security. It's AI-powered security scans for vulnerability in images, configurations, and runtime environments, which is good. Which I'm basically playing around now. I'm just trying to see how it can help. It also helps the detect anomalies and potential threats, reducing the risk of security breaches. It also optimizes the resource allocation uh, by automatically adjusting container resource requests, CPU, memory, stuff like that, based on the workload requirements. So, which is really, really, really good. So basically, you define that in your Docker Compose or file, right? How much you need, how much, those things. That now, or in your workload CCS or EKS, you define those components in your thing. So now you can use basically Gordon to optimize those requests and basically, yeah, based on your workload requirements. It results basically efficient scaling in your AI/ML applications in production environments. So yeah, and also it continues monitoring and learning. The tool continuously monitors containerized environments and learns the patterns, offering proactive suggestions to improve the performance and security and compliance. It provides a real-time alerts and insights, allowing teams to act quickly in case of any issues. And the beauty is it also integrates nicely with your CI/CD pipelines. So automating your container builds, tests, and deployment process. So this is what very useful in your pipeline before even you go. Say you can integrate Gordon in your pipeline and then basically see how your containers are secure. Is it optimized toward your SDLC, yeah, software development lifecycle. So some of the use cases would be for particularly used for like managing a complex dependencies of AI ML models. If you're playing around with new models, you want to it's very complex dependencies and ensure they are deployed efficiently within the containers. You might want to use Gordon to do to help that. Any edge computing stuff like manage containerized application at the edge, optimize resources, security, agile workloads for stuff like that. So yeah, I think it will be a game changer for organizations looking to deploy AI/ML applications with advanced security, resource optimization, and yeah, it automates complex tasks, managing AI workloads in containers, basically, so allowing team to focus on innovation. So definitely, if you, yeah, please play around, see if it's, how it helps. If you have any questions, if you want to go, deep dive in my next event, we can definitely do that. Right. Before I jump in, I just want to quickly check the chat if everything is okay. Right. I might miss some questions here, but I will come back. Yeah. Please bear with me. I'll quickly address that. Sure. So yeah, so the next one would be uh, some of the open source tools I use personally in my pipeline to reduce the size of the Docker image I build. So that will be Docker Slim. Uh, the security and efficiency is they go hand in hand. Yeah. So in containerized environments, you definitely want to use uh, look into how you optimize and secure your container images. That's the key thing. So with Docker Slim, it will definitely reduce your image size by removing any unnecessary files, binaries, libraries. It minimizes the attack surface because you basically, are stripping off all the unwanted components, making images more secure. It can automatically generate security profiles for, SecComp, AppArmor, stuff like that, and it helps you to improve performance and reduce deployment costs. So I used it in my pipeline, somehow, during my image building process. So definitely, it will just play around, see if it helps you in your hardening, images process. So let me know if you want any support on that. Grip is another open source vulnerability scanner by Anchor. Anchor is also a very popular vulnerability scanner. I use yeah, from long time ago. So I know these tools at a certain level. So it basically detects vulnerabilities in OS packages and third-party libraries, and it gives you a nice summary of what your image contains and what the things that you need to look for. It also works with Docker, Kubernetes, ECR, AWS ECR, and it also create bill of materials files as well, SPOM. Fast and developer friendly. It's definitely integrates with CI/CD. But this is the beauty of these tools. So basically, you can automate your security checks within your CI/CD pipelines, and these are the tools definitely I would recommend it. And it's not too heavy. Basically, Docker Slim is it creates very lightweight. It secures your images. Grip, it basically it detects your vulnerabilities before your deployment. So together, it basically enhance your container security and efficiency. So I definitely would ask you to just yeah look around. Right. So the next one would be the Dockerfile best practices. So this is the key before you go into any tool, before you invest or any open source tool that you would like to do. This is where you start basically. So whatever in your Docker file is reflects your image. So writing an efficient, secure, maintainable Docker file is the key to building a robust containerized applications. So some of the best practices I would like to go through is basically a minimal base image. So don't take heavy, massive base images where you want to run your container because they're pretty huge. So choose for like any Alpine, Debian to reduce any attack surface. So these are definitely, but again, take it from official, trusted, minimal based images, sources, but not from random online or GitHub thing. So please go to Docker site. So take for official Alpine sources. Make sure that's definitely must. So make sure you can trust where your base images are coming from, and yeah, run scanning before you even put in your any environment. So avoid large images that basically includes unnecessary components which you don't need for your application to run. So they increase also the security risk and image size, so which is not very viable. Leverage multi-stage builds basically in your Docker file. See how you can separate your build and runtime environments. You separate them. This will help basically to keep your final image clean, and also help to you to reducing the size of the image and potentially risk security vulnerabilities as well. So example, build your application in like one stage, then copy only the compiled binaries to the final image, so not the whole code and all, you understand. So that way you basically segregating your whole source code in your on-prem environment, for example, and basically you deploying your compiled binaries, your final image into a public cloud or ECR, and then you basically run your application. That's the secure way to do it. So avoid root user for running containers. This is, we touched a little bit on this in the previous slide. So never use any root users to run your application inside the container. So always create non-root users and give access to the developers. This will basically minimizes the impact for any potential exploits by limiting the privilege of the application. Yeah. So again, this is the principle of least privilege principle. This is a must to follow in your Docker file, in your scan, in your public cloud, wherever you create in IAM. Uh, Privilege, least privilege. So don't give blanket administrative access, blanket, predefined access. Just give the access privilege what is required, and you can control that using your policies. Minimize the number of layers. So in Docker file, I don't know if you're familiar with it. So every line you write in a Docker file is a layer, and then basically that's how it copies into your registry as well. So minimize unwanted, layers. So basically those number of layers into a. See if you can, like run, copy, add, make it like a single instruction instead of multiple lines where possible. So this minimizes the number of image layers, resulting in a smaller, faster builds. And also use like example like run apt-get update. You can use ampersand and then apt install this and then run my command, so you can use that in a single line. So one of the other one is the docker ignore file. So similar to like familiar with git ignore, if you know git, is similar to that. The Docker ignore file basically tells the Docker which files it needs to exclude from the build content. So this will help not to put the package name as part of your build, image. This also reduces the image size and prevent any sensitive files like credentials or logs which are not required from being added to the image. So this is one thing you definitely were to look into. Pin any dependencies and packages. So basically, if you have any specific versions of dependencies or and packages to avoid breaking the changes and vulnerabilities from the future updates, you definitely have to look for them. Yeah. So use like a version tags instead of latest. So like get latest image. So don't use that, because if the latest image breaks your dependencies, then your whole build will fail. Yeah. So application doesn't work. So make sure if there are any dependencies on a specific version, you pin that specific version to your base image. Like, yeah. So ensure that the builds are more repeatable and use a specific version tags. So reduce the layers by cleanup commands. So for example, like clean up temporary files, package, manager caches, unnecessary dependencies in a single step. Example, when you run apt-get, clean, and then basically remove these files, and then you can basically show that remove command in that during the build process, and then you basically minimize those image size by eliminating those unwanted files, yeah, which will generate in the build runtime. And also leverage build arguments and environment variables. So use arguments, ARG, or customizable settings during the build time. Use environment variables, env, to configure runtime settings. Any credentials or anything secure, no, any sensitive one, don't put it in the Docker file. Don't put it in your any file in open text. Definitely play clear text. You use runtime things like in GitLab. You can basically create a secure variables and pass them in the runtime environment. They won't even be visualized. You can basically mask them. In AWS, you can use in parameter store, secrets manager, and basically encrypt them as well, so nobody get access to it and able to see them. So yeah, so these are the basically best practices. You will create efficient, secure, maintainable Docker files that contribute to a better containerized application. Keep your images lean, secure, and easy to manage. Don't make it too complex. Um, yeah, and with that, I think thank you. Right. I know there's a lot of information to go through. I would definitely want you to just go through that open source ones which are mentioned. See if you have anything, any questions on any more detail that you want to like to deep dive. We can do that. For example, our Docker Gordon AI. So if you guys are interested, just let me know in the feedback form. So probably we can do that. I'm also thinking of doing a EKS auto mode session maybe next month, or in a couple of weeks. So if you are interested how the EKS auto mode works, if you're if you guys have anything, any requirement for that, I will you will see as well. So yeah, there's a lot of things on container side, a lot of AI stuff coming in. So if you guys have any questions, any feedback, please put it in the feedback form. I will definitely see if I can cover them in the coming events. So I'm looking at the chat. So basically, I will look for some questions and basically see if I can do. Dinesh, how can we integrate Docker Scout in CI/CD pipelines? I mean, depending on your CI/CD pipeline, right? So if you're using GitLab, one of your within your pipelines, basically you can do that. If you're using a code pipeline or image, you use your ECR standard, image scan on push, vulnerability scanning by default within ECR. You can also integrate some of the open source tools which are mentioned in your CI pipeline as well. How do you integrate this? Basically, you create your when you're writing your pipeline in your YAML file, you can create these stages. You can one of the stage would be a testing or vulnerability scanning. So in your pipeline, and then the scan stage is when you basically do all the scanning of your images, and then depending on the result, either you promote a deployment or you basically you reject it, go back to the development, fix it, and then basically it goes to your CI pipeline. Uh, so another question from Robert. Could you please say a few sentences of EKS pod identity? This is something which I would like to, interested to deep dive in one of my AWS event which is coming in. I want to call some Kubernetes folks from AWS. I definitely want to give a detailed session on EKS auto mode, and a more detail about that, how this whole thing works. So hold on to it, please, so that you can attend my session, upcoming session, so we can dive into more of that. So we'll have a dedicated AWS speaker coming to talk about the auto mode, and also pod, I know the some components of how EKS do all the pod identity and stuff like that. Cool. Any other questions? Thanks, Tiki. Thanks for joining. Thanks, Robert. Thanks, Gerald. He's a key man behind the scenes running the show, but he's not visible here. But yeah, thanks, Gerald, for all your support, what you do to the community as well. So thanks, guys. I think with that, we can wrap up. We don't have to wait for an hour. So, but please don't forget to, fill the feedback form. I have some credits to give away. So please, I want them to you to use it. Run the see create a pipeline. Run some of your ECR scans. See how it goes, and just give me some feedback. If you want to drill down more, use those open source tools which I gave you. Yeah, run on EKS environment, ECS environment. Or Fargate. You can use these credits to do all that. It will basically compensate. You don't have to use your own money. And then yeah, please give me the feedback on yeah. So there are two more sessions which I'm planning in my mind. So one is EKS auto mode. Behind the scenes, basically it's a carpenter and some open source tools, and we will deep dive into more detail. And the other one would be a Docker Garden AI, which I would like to also uh, yeah, see if people are interested, we can arrange a dedicated session for that, or we will see. So I think that's all from my side. Thanks, Dinesh. Then thank you guys. Thanks for joining. Don't forget to fill the feedback form. That's how I'm going to send you my AWS credits. So thank you guys. Thanks for joining.